Last problem. Well, second last. Number 34 is last. It says the accompanying table shows wind speeds and the corresponding wind chill factor when the air temperature is 10 degrees Fahrenheit. And here we have the x, we have wind speed, 4 miles an hour, 5, 12, 16, 22, and the wind chill factor. So when the wind is blowing at 4 miles an hour and the air temperature is 10 degrees Fahrenheit, it feels like it's actually 3 degrees Fahrenheit. When the wind is blowing at 22 miles an hour and the air is 10 degrees Fahrenheit, it feels like it's negative 10 degrees Fahrenheit. And this, if you live in a cold area, you know this. In the winter, when the wind blows, it feels much, much colder than if the wind is not blowing. Okay, and what we want to do here is write the logarithmic regression equation for this set of data, rounding coefficients to the nearest 10,000th. So that's 4 decimal places. Okay, and that's the first thing. The second thing is, using this equation, find the wind chill factor to the nearest degree when the wind speed is 50 miles an hour. Okay? And the third thing they want us to do is, based on your equation, if the wind chill factor is 0, what is the wind speed to the nearest mile per hour? Okay, so the first thing we have to do is enter this data into our enter it into our calculator and come up with a logarithmic regression. Unfortunately, I don't have screen capture abilities for calculators. I did this using this program here called OpenOffice Calculator, or openoffice.org calc. It's really, really cool. It's basically Microsoft Excel. And I've come up with this equation, negative 7.3135 times natural log x plus 13.0134. And the r squared is a regression. That's how well it fits, and it fits the data very, very well. 0.9981 is almost a perfect fit. The closer to 1, the closer you are to perfect. So that's our equation, and here is the data that I did. And I'm not going to go through all the steps on how to do this using calc. Maybe if someone requests it, I'll do it later. But you should know how to get this equation out of your calculator. Now that we have that equation, so we have y equals negative 7.3135 times natural log x plus, that's a plus sign, plus 13.0134, 0134. That's our equation. So that's part A right there. Part 1 is done. Okay, and we've rounded to the 4 decimal places. Okay, now it says, using this equation, find the wind chill factor to the nearest degree when the wind speed is 50 miles per hour. So basically, where I see x, because x is wind speed, see, wind speed, x is wind speed. When the wind speed, when the wind speed is 50 miles an hour, basically I'm just going to do y equals, and then negative 7.3135 times, I'm just going to call that k, times natural log of 50 plus, and we'll just call this b, right? Okay, so basically I'm just doing straight computation now, and the answer is going to be y for part 2. Now, if you have a calculator, you can go and take out your calculator and put that in. I want to show you something nifty here that I think you might find interesting. Google is a calculator. You can enter in mathematical terms on Google, and you can get answers. So the answer here, if we go into just google.com, type in negative 0.73135 times, that's the star key, that's shift 8, times natural log of 50 plus 13.0134, press equal, hit search, it comes up with the answer. The answer is negative 15.971803, blah, 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 goes on and on. But they are looking for the nearest degree. If you look at number 2, it says nearest degree. So negative 15.59, that's going to be, y is approximately negative 16 degrees Fahrenheit. So that's your answer for number 2. Okay, bet you didn't know that about Google. Now you do. Okay, number 3, it says, based on your equation, if the wind chill factor is 0 degrees, what is the wind speed to the nearest mile per hour? Okay? If the wind chill factor is 0 degrees, what is the wind speed to the nearest mile per hour? Well, now it says the wind chill factor, that's y. Okay, y is equal to 0. So what we have now is 0 equals k times natural log of x. And again, I'm just using k in place of negative 73135 because I don't want to write it all those times, plus b, where b is 13.0134, right? And y, wind chill factor, is set equal to 0. I want to know what the wind speed is. Wind speed is x. So I want to solve this for x. So I'm going to subtract b from both sides, and I'm going to get minus b equals k times natural log x. And then I'm going to divide by k. Okay, so I'm going to have natural log x equals minus b over k. And then I want to, again, I want to solve for x, and the way to solve for x is to basically raise both sides of this equation like this, right? E to the this equals e to the natural log of x. So basically e to the negative b over k is equal to e and natural log cancel each other out, so that's x. Right? So this just means e to the negative 13 point, oh, what was it? 0134, 134 divided by, and then k is negative 7.3135. And that's the answer. That's equal to x. And again, they want it to nearest mile per hour, right? They want this to the nearest mile per hour. So again, I'm going to pull up Google, and I can calculate negative 13.0134 divided by negative 7.3135, get an answer. Or if you really want to be fancy, and you have to be really careful with parentheses, you can type in e, that little caret, that's the shift of the 6 key, little caret symbol. So e raised to the power negative 13 blah 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 divided by negative 7 point blah 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 equals, and we get 5.9261 and so on and so on. But we want it to the nearest degree, so 5.9, that rounds up to 6, and we're in miles per hour, so this is mph. So that is the answer for number 3. Okay, hope you found this useful.